Meta's $162 billion AI gamble and sweeping workforce restructuring, NVIDIA's GTC sweep declaring the physical AI and inference revolution, and OpenAI's aggressive pivot to enterprise dominance. If you're trying to navigate these massive tectonic shifts and keep up with the latest models, you already know things move incredibly fast. Welcome to inuku.com, AI news you can use, your daily dose of AI know-how. What I'm noticing in the tech space this quarter is a phenomenal reallocation of capital. We are watching the entire artificial intelligence space violently pivot away from consumer toys and chat interfaces toward massive, industrial-scale physical infrastructure. The sheer amount of concrete being poured for data centers right now is unprecedented. Look at Meta. Imagine waking up to find out a tech giant is planning to lay off approximately 20% of their workforce. That's roughly 15,000 jobs by 2026. This isn't because the company is failing, and it's not a market crash. It's because they desperately need to double their R&D budget to an astonishing $135 billion. It is the ultimate definition of betting the farm. The driver behind this drastic move is a very real bottleneck. Their next-generation frontier AI model, internally called Avocado, has faced serious developmental delays. When you're fighting for dominance in the frontier model space, any delay means you risk losing the hardware arms race. So to guarantee they have the compute power to simply brute force through those delays, Meta just locked in a monumental 5-year, $27 billion infrastructure agreement with Nebius. Nebius is providing $12 billion in dedicated compute infrastructure right out of the gate, and Meta is committing another $15 billion to purchase upcoming clusters. And the bedrock of every single one of those clusters is the NVIDIA Vera Rubin platform. Speaking of NVIDIA, they essentially stood on stage at their GTC 2026 conference and declared themselves the foundation of the entire global economy. They are forecasting up to $1 trillion in revenue by 2027. They can make that forecast because they have completely shifted their core architecture. For the last few years, the entire industry was obsessed with training the models, sticking thousands of GPUs in a room to make the AI smarter. But now the models are trained. NVIDIA is laser-focused on inference. For those tracking the technical shifts, inference is the act of actually using the AI, taking the trained model and deploying it to generate responses or make decisions in the real world. Their new Vera Rubin platform includes 7 new chips and 5 entirely different rack types, all designed to accommodate this specific shift. When you pair their Rubin GPUs and Vera CPUs with the new Grok 3 LPX accelerator, the metric they keep shouting from the rooftops is that it delivers 50 times higher inference throughput per megawatt compared to older generations. Why is throughput per megawatt the only metric that matters right now? Because these AI models are answering billions of queries a second across the globe. It is no longer about raw intelligence. It is about how cheaply and efficiently the AI can think without literally melting the local power grid. If you're operating a massive server farm, your ultimate limit isn't how many chips you can afford to buy. It's how much electricity the local utility company can legally route to your building. It's an electricity bottleneck, not just a compute bottleneck. They are attacking that efficiency problem on the software side too. They just launched Dynamo 1.0, an operating system specifically engineered for AI factories. Just by installing that OS, it boosts their older Blackwell inference speeds by up to 7 times, simply by stopping the hardware from wasting idle power cycles. But you cannot have all this processing speed if the processors are starved for data. That is exactly why Samsung's new 6th generation HBM4 and HBM4E memory architecture is so integral to this rollout. Memory bandwidth is the silent killer of AI performance. Imagine having a massive, hyper-advanced commercial printing press, but you're feeding it ink through a medicine dropper. The machine just stalls. Samsung is basically replacing that dropper with an industrial pipeline. Their new architecture is custom designed for the Vera Rubin platform, pushing processing speeds to an incredible 11.7 gigabits per second, allowing the processor to instantly access the massive data sets it needs without waiting around. So with all this raw, mind-boggling power and memory pipelines the size of fire hoses, where is all this intelligence actually going? It's not just generating better email replies. The compute is actively escaping the data center and moving directly into physical spaces. NVIDIA just rolled out the Alpamayo 1.5 system. It is a reasoning-based autonomous vehicle system, and crucially, it runs alongside a real-time safety layer called Halos OS. A chatbot hallucinating a spreadsheet formula is annoying, but an AI misidentifying a pedestrian crossing at highway speeds is lethal. Halos OS basically acts as the hard-coded brake pedal, and they are pushing this into production fast. NVIDIA is partnering with Uber to launch Level 4 robotaxis in 28 different cities by 2028. They have the financial and manufacturing backing of GM, Toyota, Mercedes-Benz, Hyundai, BYD, and NIO. Even Amazon is making a massive play here, partnering with NVIDIA to bring the Alexa custom assistant directly into these in-vehicle experiences. You won't just be riding in the car, you'll be having a deeply contextual conversation with the vehicle itself. But to get robots and vehicles to actually function out there in the chaos of a city street, you need an incomprehensible amount of training data. You can't just unleash 1 million robotaxis into downtown traffic and let them crash to learn how to drive. That is why NVIDIA's Physical AI Data Factory Blueprint is arguably their most important announcement. Powered by their Cosmos world models, it generates synthetic training data at a massive scale for robotics companies like ABB and Figure. Think of it this way. Imagine an automated forklift trying to pick up a wooden pallet that has a weird splintered edge and is covered in a layer of frost. You cannot manually write the code for how to handle that exact physical texture. It's impossible. Instead, Cosmos generates a hyper-realistic digital simulation where that robot can experience 1 million different variations of lighting, gravity, friction, and moisture before its physical metal body ever takes a single step on a real warehouse floor. The physics engines making those simulations possible are so versatile that NVIDIA is bringing that exact same compute power to the entertainment sector with DLSS 5. The same AI that simulates lighting and shadow for a warehouse robot is now generating film-quality real-time AI lighting in video games without causing any drop in frame rates. And perhaps the most jaw-dropping physical deployment is the Vera Rubin Space One module. They have engineered the hardware to run AI directly on satellites in orbit, in the literal vacuum of space. Historically, a satellite takes high-resolution imagery and beams petabytes of raw data back down to Earth. Then a massive server farm on the ground analyzes the images to look for anomalies, which takes time. Putting AI in orbit changes that entirely. It gives the satellite its own independent brain. It analyzes the imagery locally in orbit, realizes there is an issue, and beams down a tiny instantaneous text file with the exact GPS coordinates. The communication lag drops to absolute zero. So, the physical world and low Earth orbit are being locked down. But meanwhile, back on the ground, the software giants are fighting a totally different, incredibly bloody war for the enterprise sector. The era of the generic chatbot is officially over. Integrating AI into deep corporate workflows is the new gold rush. OpenAI is feeling immense pressure here. It's a direct defensive maneuver against Anthropic, who has just been quietly eating their lunch in the corporate sector. So, OpenAI is aggressively halting experimental side projects to completely refocus their engineering talent on coding and enterprise users. They recognize that having the smartest model doesn't matter if it isn't integrated into where people actually work. To secure this, they are putting together a massive joint deployment venture with heavy-hitting private equity firms, TPG, Bain, Brookfield, and Advent. We are looking at a pre-money valuation of $10 billion, with those firms committing $4 billion. In return, they get equity, board seats, and most importantly, they commit to driving OpenAI integration across their massive portfolios of acquired companies. It's a flawless distribution play. OpenAI doesn't have to sell to 1,000 CEOs. They sell to Bain, and Bain forces the adoption across every company they own. The sheer volume is already mind-bending. Following the launch of GPT 5.4, OpenAI saw their API usage jump 20%. They are hitting 5 trillion tokens processed per day. Their frontier AI platform is seeing adoption rates so high that it is actively causing severe power grid constraints in certain deployment regions. On top of component shortages, The physical infrastructure can barely keep up with the software demand. It gives massive context to CEO Sam Altman recently telling a crowd of college sophomores that they will literally graduate into a world with artificial general intelligence. When your models process 5 trillion tokens a day and strain regional electrical grids, AGI stops sounding like a philosophical debate and starts sounding like a scheduled product release. Massive global corporations are restructuring their entire foundations to prepare for it. Look at IBM. They just completed an $11 billion cash acquisition of Confluent, a major data streaming platform. At first glance, paying $11 billion for a data pipeline sounds dry compared to a frontier model, but it's brilliant. Think about a global logistics firm. If you use an AI trained on last month's weather data, it could confidently route a fleet of delivery trucks straight into a massive blizzard. Enterprise AI is entirely useless if it's looking in the rearview mirror. Confluent feeds real-time, live operational data directly into IBM's watsonx.data and mainframe systems. It transitions companies away from static datasets into dynamic models powered by continuously updated business reality. We are seeing this realization trigger massive internal shakeups everywhere. Alibaba is completely revamping their corporate structure, creating the Alibaba Token Hub. They are taking their Quinn AI research team, consumer apps, DingTalk, and Quark devices, and consolidating them under one unified roof to eliminate silos and accelerate profitability. But Apple is playing a totally different game. Their $14 billion investment into AI this year looks like pocket change compared to Meta's $135 billion. That's because Apple is making a massive, calculated bet on edge AI, running the intelligence locally on the device itself. They are operating under the assumption that massive cloud-based models will eventually commoditize, and the real value lies in owning the endpoint where the user interacts with the intelligence. Reflecting this strategy, they just launched the AirPods Max 2, powered by the new H2 chip. It runs Apple Intelligence for live, real-time translation right on the device, alongside voice isolation. It never has to ping a server. It happens locally, instantaneously. The underlying current driving all this infrastructure demand from the corporate world is a fundamental shift in how we use the technology. We are moving away from conversational AI to the agentic workforce. We are transitioning from generic chatbots that just answer our questions toward autonomous agents that actually execute complex workflows. Projections are staggering. By 2028, over 80% of governments globally will utilize agentic AI to automate routine decision-making processes. Because the market is ruthlessly demanding utility, we are seeing massive churn rates across generic AI apps right now. People are just unsubscribing. The novelty of simply chatting with the computer has worn off. If the AI isn't autonomously saving a user hours of tedious work, they cancel the subscription. That demand for autonomy is exactly why NVIDIA is stepping in with the NemoClaw OS. It is an operating system explicitly designed to let agents act autonomously inside highly secure corporate environments, built on top of their OpenShell safety layer to ensure they don't go rogue. Startups are capitalizing on this autonomy faster than anyone expected. Okara rolled out an AI CMO that doesn't just write blog posts. It actively deploys specialized marketing agents across a company's SEO pipeline, content creation, and social media channels. It analyzes the metrics, adjusts the strategy, and executes the campaigns. It's an entire marketing department wrapped in a software suite. The open source community is moving just as aggressively. Mistral AI, as part of the new Nemotron coalition backed by NVIDIA, released Leanstral. This is an open source agent specifically designed for the Lean 4 programming environment, launched right alongside their Mistral Small 4 model for advanced coding and document analysis. For context, Lean 4 is a highly precise language heavily used in mathematical proofs and formal software verification, so having an agent fine-tuned for it brings incredible accuracy to developer environments. But the shift that will really change how we work every day is happening at the OS and browser levels. The Dia browser integrates deeply with your existing tools like Slack and Notion, turning the browser itself into a cross-application AI operating system. The browser can read your Open CRM tab, notice a new lead, autonomously draft a Slack message to your sales team, and log that entire interaction in your Notion database, all without you ever clicking between the windows. Manus AI is pushing the boundary even further with a desktop application called My Computer. It allows their AI agent to work directly on macOS and Windows devices, running raw command line tasks utilizing your computer's local GPU resources. Handing over the actual command line keys of your machine to an autonomous agent is a lot of trust. But look at the enterprise utility. Imagine an agent that dives into your corporate HR software, cross-references payroll with contractor invoices, and autonomously reallocates project budgets overnight to save hundreds of thousands of dollars. That level of undeniable financial utility is why the corporate world is accepting the risk. And that risk bridges us perfectly into the glaring friction the entire industry is slamming into right now. The hardware is scaling beautifully, the agents are deploying, but the security guardrails are failing miserably. We are building trillion-dollar hyper-intelligent brains, yet a new benchmark reveals that 75% of security leaders are guarding these systems with legacy endpoint controls. It is the equivalent of trying to stop a high-powered laser beam with a chain-link fence. Only 11% of companies have actually implemented AI-specific security tools. The vulnerability isn't just at the corporate endpoint, it is baked into the foundation. The software supply chain is incredibly fragile right now because virtually all of this advanced AI development relies heavily on open-source libraries. If one core library gets compromised, the entire agentic workforce is vulnerable. That is exactly why Anthropic, AWS, GitHub, Google, DeepMind, Microsoft, and OpenAI just locked arms with the Linux Foundation to deploy a $12.5 million grant strictly to secure that open-source infrastructure. Because when an autonomous system makes a critical mistake, the legal liability becomes an existential threat to the whole sector. We are already seeing those existential threats materialize in healthcare. ChatGPT Health currently handles 230 million weekly users, but independent safety evaluations of that tool reveal terrifying bias. The system actively downplayed actual severe medical emergencies 51.6% of the time, confidently telling patients to just schedule a routine doctor visit. On the flip side, it unnecessarily escalated incredibly routine, minor cases 64.8% of the time. The underlying issue is statistical averaging. The model averages out symptoms to the most common denominator, completely missing the nuanced edge cases that a human doctor would spot instantly. When a model gives dangerous medical advice without human oversight, the legal frameworks surrounding liability escalate rapidly. The lawsuits are piling up across the board. There is a massive class action lawsuit filed against Elon Musk's xAI by 3 teenagers, alleging the company completely failed to implement necessary safeguards or watermarks, allowing third-party applications to generate explicit images of them without consent. We are seeing similar legal action against Google. A lawsuit targeting their Gemini chatbot claims the AI's persistent hallucinations contributed directly to a fatal delusion for a user. And this tension is only amplifying in the defense sector, where the U.S. military is currently utilizing Anthropic's Claude model for national security operations. When national security relies on a model prone to hallucination, the stakes literally could not be higher. If we connect all these legal nightmares and safety failures, the root cause almost always traces back to the exact same thing: the training data. If you want these models to be safe, accurate, and reliable, you have to fix the foundational data pipeline to ground them in absolute reality. And the data shortage is a critical bottleneck right now. The models have consumed almost the entire public internet. To counter this, U.S. Senators Ted Budd and Andy Kim recently introduced bipartisan legislation mandating the National Institute of Standards and Technology to establish rigorous guidelines for formatting all federal government data so it is perfectly structured for AI ingestion. It's a massive, coordinated push to unlock new, high-quality data sources to fuel domestic innovation. While the government is legislating data, the private sector is getting incredibly creative with how they harvest it. Niantic Spatial Mapping just revealed that they used over 30 billion images captured purely by everyday people playing Pokemon Go on their phones to train a highly accurate 3D spatial mapping system. They partnered with Coco Robotics. Because millions of people were walking around catching virtual monsters, they built the exact hyper-detailed digital map that allows an autonomous courier to navigate right to your front door with your new pair of sneakers, even when the satellite signal is completely blocked. It highlights how valuable localized, grounded data truly is. On the consumer side, we are also witnessing a deep psychological shift. Users are feeling increasingly helpless against algorithmic determinism. People are tired of an AI dictating what they see, so companies are starting to hand the steering wheel back. Google is rolling out Canvas directly inside its AI search. Instead of just giving you a final answer, Canvas turns your search results into an interactive, localized workspace where you can manually build, tweak, and structure the information yourself. Spotify is tapping into that exact same frustration. They are launching a beta feature for premium users that lets you manually edit your algorithmic taste profile using natural language. Let's say the algorithm thinks you're a fanatic for 1980s synth pop. Just because you listened to one retro playlist at a Halloween party 5 years ago. You no longer have to be tracked by that data point. You can literally just type to the AI, "I'm over it. Stop pushing synthesizers on me," and it immediately rewrites your profile. Giving humans direct natural language control over the algorithms that shape their digital reality is vital. Before we get into the final takeaways, just a reminder that you can find more insights like this at ainuku.com, your ultimate hub for navigating the AI transition. Let's bring this all full circle. We are looking at $600 billion in total infrastructure spending happening right now across the industry. When you look at the sheer scale of what is being built, from Uber's robotaxis to autonomous cloud auditing agents to satellite brains in orbit, that massive capital expenditure makes perfect sense. The generative AI honeymoon phase is officially over. We are firmly entrenched in the industrial deployment era. Between NVIDIA's relentless physical compute rollout, Meta's breathtaking $135 billion budget, and big tech tapping massive debt markets to build server cities, the conclusion is unavoidable. Compute is the new global utility. It is going to power our vehicles, run our corporate workflows, and manage our data centers. But while the hardware is ready to scale, the frameworks required to manage this technology safely, the enterprise security, the legal safeguards, and the healthcare accuracy are still lagging dangerously behind. If compute is officially the new global utility, what happens when it becomes as heavily regulated as water or electricity? Are we heading toward a reality where your access to thinking power is metered by the state, and you have to ration your AI usage during peak hours just to avoid surging your utility bill? Something to think about the next time you ask an agent to execute a task for you. And that's your daily dose of AI know-how from ainuku.com, AI news you can use. The biggest takeaway today is that the conversation has moved entirely past the chat box. The physical infrastructure for autonomous agentic AI is already being poured globally, and if you want to stay relevant, it's time to build your enterprise strategy entirely around uncompromised utility. Catch you on the next one.